Hello, ladies and gentlemen. My name is Leandre Adifon. I'm the founder of the African School of Economics, but also professor of politics, economics, and international affairs at Princeton University in the US. So welcome to the Summer Institute for Economic Research. It's the second edition. And as usual, like we did last year, at the end of the school, we have a keynote speech on an important topic by a distinguished scholar or practitioner. This year, we are very lucky to have Mr. Leandre Adifon. Leandre is a great friend of mine, but more importantly, in this context, he's the Vice President for Enterprise Systems Engineering and Advanced Technology at Ingersoll Rand. In his current role, Leandre oversees program and portfolio management, systems engineering, and advanced technology at the company. Until recently, he led engineering and technology for the industrial technology sector, including compressed air technology, power tools, fluid management, material handling, and club car. Leandre came to Ingersoll Rand after 20 years at United Technology, where he was vice president of Otis Worldwide Engineering and a member of Otis Executive Committee. He held various roles of increasing responsibility within United Technology, including vice president of elevator system engineering and development, director for engineering for North and South America, and senior manager for systems engineering worldwide, among others. Prior to joining United Technologies, Leandre was consultant in robotics, machine tools, and thermal engineering in Europe. He holds advanced degrees in mechanical engineering from Polytechnic of Milan in Italy, and in management and finance technology from Rensselaer Polytechnic Institute, RPI. He also has an MBA from RPI and certificate in system design and management from MIT. Leandre speaks several languages, including French, which is his native language, Italian, Spanish, and some German. He is a member of the International Council for System Engineering, Global Architecture Forum, and American Society of Mechanical Engineers. He's also a board member of American School of the Deaf, and more importantly, I should say, as importantly at least, he's a board member of the African School of Economics. It's such a great pleasure having him among us today, and we hope that he will give an extremely insightful and inspirational speech, and we are lucky that at the end of the summer school, we have such an opportunity to get someone of his caliber, to inspire us and to look ahead to how technology is going to shape our lives and the globe for the 12 years to come. Thank you very much.
Good morning, ladies and gentlemen. It is for me a delight to be here in my native Benin to talk to you and review together the challenges as well as the opportunities in the developing countries as we journey toward 2030. It is important that we put technology in its own environment, and then we have a healthy discussion about it. I will start with one of my favorite pictures. If you look at this picture here, you see the surface of the moon, where NASA astronauts took a picture of the Earth. And just like you would see the moon in the night overhead in the sky, we are looking at Earth in the sky. But the message is clear. It tells us that this is the only place we all call home. This is the only place we all call home. And the only inhabited place we know of so far. Every now and then, we are told that we found a planet that is close and looks like Earth-like environment, but so far no other planet is inhabited. The question, though, and the problem is that planet Earth is being suffocated by some dark spots, namely hunger, disease, illiteracy, inequality, poverty. We still have communities in the 21st century that live without electricity, with no water. And that is something that we need to come together and work in such a way that we can remove the dark spots in order to brighten the earth. The context in which we'll be talking today is the context of the United Nations goals. The United Nations, in fact, have set 17 goals. And as you can see them here on the board, they range from no poverty, no hunger, all the way to partnership to meet the goals. So we will take those goals as our background, extract some of them, and talk about technologies that are needed to fulfill them in our generation. However, before we go any further, I will leave you with this notion in such a way that you keep that in mind for the rest of the discussion. Let's look at a few economic cycles. We are, and it's appropriate, we are at the African School of Economics with bright minds in the room that really understand analytics and so on. So let's look at a few cycles. If we look at hunting and gathering, as you can see, for 1 million BC and still going. Still going. You look at agriculture, 10,000 BC and still going. What we're measuring here on this graph is how long it takes to each of those technologies to reach 100%. If we look at another one, industry, 1800 AD, and still going. And yet, if I take nanotechnology, as recent as 2015, this technology has reached gigantic levels and growing. Now, what is the takeaway from this? It is that economic cycles are getting shorter and shorter. Please keep that notion in mind as we progress. 14 years ago, only 14 years ago, there were no smartphones. 14 years ago, think about this. There were no smartphones. There was no GPS. GPS, the countries where they have digitized maps, you get in your car, you put the address where you want to go, and then the car drives you there with left, right turns, and you get to your point. That did not exist 14 years ago. 14 years ago, there were no Facebook, no Twitter. There were no social media. There were no 3D printers. I will come back to 3D printing and talk to you about that technology. Fascinating, growing, and changing the industries in the world. I'll come back to that. The cloud. What is the cloud? The concept of cloud is that instead of having your documents on a computer, you leverage a network of computers around the world. So it doesn't matter where your document resides, as long as you have access to it anytime you need it. That is the cloud, the concept of cloud. 14 years ago, there was no cloud. E-readers, Kindle started, and now all of us have e-books, and we read the books. So the list could be even longer. So this thing, 14 years ago, did not exist. So 14 years from now, imagine what can happen, what we can be part of, and what can happen in the world. And that's exactly where I want to drive us today. what can happen 14 years from now. And we need to be part of it so that we don't feel like fish out of a water that's drying and then refuse to follow the water as it's drying from its edges. If they don't follow and adapt, they will get lost. They will be left out, and we don't want to be. Not only we want to be part of the transformation, but we want to be also actors of the transformation and be part of it and make it happen. So let's get on this journey and examine a few technologies. This is very important. What you see on my left here are all telephone lines. For people who are 40 and over, you know very well these telephone lines. You go somewhere, they're everywhere. It requires investment and infrastructure to get all these lines. And this phone was the phone that some of us have started using telephone with. And then once we moved to hand-free, it was wonderful. You could go in the garden around your house without having to be tethered to a base. But then what happened? What happened is that we went to cell towers and look here, this mountain of handheld devices, cell phones, and so on. And when you look at this, the message here is that in some countries, developing countries, they did not invest at all in all this infrastructure. They directly jumped from this to that, which means that it is possible for developing countries to jump over an entire generation of technologies. I talked to you about fast cycles, and now I'm giving you the notion of skipping over entire generations. Keep those two things in mind as we now examine a few technologies. Here are the 6 that we will talk about. I will talk about a few technologies, just grab a couple. It's not to go over a whole list. Our time is limited here, but I want to stimulate your creativity. We talk about research, your sensitivity to pay attention to these and to be part of them as they unfold. So I'll be covering each of these and say a few words about them and share a few technologies. Then we will open up for Q&A where I can expand as I answer the questions. Zero hunger. The part of zero hunger I'm talking about will be food and agriculture. There are 2 main drivers here. Lands. Quality lands are less and less. The world population is growing, and by the time we get to 2030, it will be getting closer to 9 billion. We are at 7 billion now. It will be getting closer to 9 billion. So planet Earth, the Earth is what it is, okay? Limited lands. So we need quality lands, and we need water. We need to use less water. Water is all around us, but unfortunately, only 2% of the water that is in the world is fresh water. Only 2% of all the water is fresh, and only a quarter of that 2% is accessible to people. So when I talk about water, I'll come back to that and talk to you about the sources of water in 2030. Okay? So here, I'll talk about 2 technologies, but those technologies are evolving. But all new technologies are being explored in order to reduce land needs and then less water. So if you haven't heard about hydroponics are technologies that use less water and bring nutrient directly to the core of the plant, just what they need to grow. And I've put here 3 different techniques. One is called the wick system. The wick system is using a wick. The wick here mostly used could be coconut. When you take a coconut and you open it, the coconut, inside, outside of the shell, what you have there is the wick. And you can just put that here and put the plants in and have water circulating in, and the plant will be soaked into that wick and will grow. The next one is a drip system. It just drips the water just exactly where the plants are. And this water is recycled. You see here, the water that's not used comes back underneath. And then the next one is called the nutrient film technique. And I'll show you a couple of pictures that show what they look like. So here you have the roots that are directly getting the water. And here you see they use tubes, and those tubes have a whole garden is here on just that device, a whole garden. Less land with this cultivation. We can grow crops without any land right in our backyard. But this is not about these technologies. It's all the things that are happening and the research that are going on to reduce the usage of land. Here, you see vertical farming. In the future, buildings will become farms. Side of the buildings, top of the buildings. It's always interesting when I go and some places in China, and you see that on top of the buildings, people have gardens already. And in the future, these will be how people will be farming. Can you imagine if in the developing countries we adopt these? Not only we create food, but the people who will be building all these vertical devices are getting jobs. They are building, they are creating these, and we have vertical farming. And that drives intensive production on a very small footprint. Let's move to the next one and talk about health. How will people be cured in the future? I will talk about two technologies, just two, again. 3D printing. If you haven't heard about 3D printing, here's what it is about. It's existed a long time ago. And yet, the last 10 years, it took a different turn because the technologies behind it started to mature. What it is that we are actually printing anything we can print. The way it works is that you build anything layer by layer. You put a layer on top. It could be plastic, it could be metal, it could be any alloys. You just build layer by layer, and you start here. You build, as you can see, it builds on top of it all the way through. What is happening, it is now mature in dentistry to use 3D printing to print prosthetics for people, and it matches them exactly. They will use a photo of the cavities, and then we'll create the model, and then we'll create and build. These are printed. They look like real, they are printed, and they match exactly the person's needs. This is a limb, and that is 3D printed, that somebody is wearing, and it matches exactly the person's needs. A person has broken the skull, and they printed exactly the part that was missing, and they put in. Now, 3D printing has gone beyond mechanical applications. In year 2030, some restaurant in the world will be printing food. You will go and get your cake, and they'll print the cake for you. Today, we cannot imagine that. But in 2030, restaurant will be printing food. Some researchers have started growing tissues, and then they will print organs for people, because so many people die in the world without having the opportunity to receive an organ from a donor. But by taking tissues from those people, those tissues will be grown, and they will be printing liver, part of the lung, part of the kidneys, they will be printed. And then you wait, the doctor, they will print your organ and then put that in you like a spare part. It is not far. By the year 2030, those things will become normal. Okay? So today we think about and we say, how can people do that? It is happening slowly but fast. That may seem a contradiction to say slowly but fast. It is happening surely. That's what I meant. Wearables. I myself here, I have two wearables on me. This is an Apple Watch and this is a Fitbit. And they are monitoring part of vital signs from me. So wearables are now a huge and exploding business. What is happening here, you see all different kinds. They are taking signs and are monitoring the heart, are monitoring other signs, blood pressure, and so on everyone. So let me give you a scenario of something that we will see in our lifetime. But before that, wearables are so exploded, the market is growing so fast that more than 100 million wearables will be shipped by 2021. And the people will be spending, the revenue will reach 18 billion by 2021. 18 billion US dollars by 2021. Now, let's fast forward ourselves to 2030 and we go and see our doctor. We won't need to see the doctor for everything because the wearable in this case will be monitoring the heart. And then we will be able to download directly that, just like my watch is synced with my telephone. All the vital signs that I'm tracking on myself are going on my telephone right away. We will get the vital sign that will go to the cloud. I talk you to the cloud, and my doctor can visualize that anywhere in the world. So can you imagine bringing devices into remote villages? In remote villages, where people will have using wearables because the cost will be going down and down. Now, everybody has smartphones around the world. Everybody has smartphones. So having access to very good care will not be only for the developed countries, but we will be able to have very good doctors around the world examine people and through these devices. I'm just pointing out here one scenario, but there could be many of them. Here are some diseases that I think can be attacked. Take heart failure. Somebody wakes up and they said he had heart attack and he died. Well, warning sign will be given by the wearable that will say, we are monitoring your heart, something is happening here. And will give an alarm, and the person will be in alarm and will be able to contact a doctor before it's too late. So heart failure is something. Obesity. We will have very smart scales. When you wake up in the morning and you go on the scale will take your weight, will be graphing your weight because you will input your name in it, and as you do that, the scale will communicate to you and to your doctor that something is wrong. There is a pattern recognition, something is wrong. The scale itself. And also the wearables will tell you. Hypertension, continuous blood pressure monitoring. So there are a few diseases. Okay, diabetes, you could be controlling your glucose and so on. And administer the medication you need automatically. So we are going toward technological advances that make somebody to say that in the next 20 years, the world will advance at a pace and be at a place that is bigger than anything we've seen so far for millennia in the next 20 years. So it will be faster and faster. So cycle will be faster and faster. Let's talk about education for a minute. The technologies I will cover are the internet, global libraries, and the virtual office to describe a few scenarios for you in the future. Here is what a futurist, Thomas Frey. I like Thomas Frey a lot. If you can research his name, go and read things that he says. He gathers futurists, and then he interviews them. He himself is a futurist. And they talk about things that are yet to come based on technologies. And what he says is by 2030, the world's largest internet company will be in education business. It will be in education business, and it will be a company we have not yet heard of. So the company today does not exist, but will be the largest company, internet company, in the next, by 2030. Everybody, when we talk about the internet here, everybody knows what the internet is. We use the internet to communicate. All of us are communicating. Well, the totally connected world is almost here. The only reason why I don't say it is here is simply because of the cost that is dropping. And I know there are some NGOs that are working to bring internet everywhere on the planet at affordable cost. But once we have that network of communications, what can we do with it? Today, we can access resources from anywhere in the world. Global libraries. What used to be the small library of a village is now a global library. You can have access to resources around the world, anywhere around the world. So what does it mean to us? It means to us that we need to go back and review the fundamentals of how people learn. How professors today need to stay current to be able to teach again in the future. Will we continue to have people grabbing books and reading books? We have to redesign the education model. The current education models by 2030 will be obsolete because we need to make sure that we follow every person's ability to learn and stimulate them and understand their strengths and weaknesses so that we can drive them to the peak of their performance in the areas where they're good, for the greater good of humanity. So education system needs to redesign itself and needs to be reviewed. And in the developing countries, the challenge is same as the developed countries. So this is not a challenge just for the developing countries, it is for everybody. So any developing country can embrace this change, understand it, and be even ahead of developed countries because this is coming in and is coming in very fast. Today, when you go to big nations, you go to the capitals or big cities, and these are office buildings, skyscrapers. Everybody drives in the morning. For the professor who's from UCLA here, ask him a minute. Los Angeles. I'm always scared when I'm in Los Angeles because of the traffic. You can't move. It takes forever because everybody's on those highways going to work. Well, it won't be for long because these will transform themselves. People from their homes will be working using means that will enable them to be seen by their colleagues, and they will be interacting normally. Today, the technology is to use Skype. In the future, with virtual reality, you will bring everybody in a virtual environment. You don't even need to use avatars. You use yourself. Without teleporting, you will be at your home, and you will be together and see all your other colleagues, and you will be talking to yourselves, and you share documents, and you don't have to drive, and this will reduce pollution. This will reduce carbon emission on our planet. And it has another benefit, it will increase productivity. Because the time people take to go to work is a wasted time. It will increase productivity, it will give them a better life, they will stay closer to their families, and this is coming at a faster pace. But here is something for the developing countries. Having a good education is good. It is fundamental. because we can be employed by employers from anywhere in the world. Because we can be in our house, in any place, in India, in Benin, we could be in Latin America, in Peru, and be working for a company in Germany, in France, in Benin, in South Africa. Because in the virtual environment, the boundaries mean less. Okay, so having a good education is good. Competent people will be employed globally. So it is good to embrace what we are good at and be best at it, so we can make a difference. Let's talk about clean water and sanitation. I was saying earlier that only 2% of the water we have is fresh water. And of that, a quarter of it is accessible to people. So where are we going? Where are we today with water? And where are we going tomorrow? And where will we be in 2030? Today, the technology used is called desalination. Desalination is growing, and if you go to the Arabian Peninsula, you go to Kuwait, you go to UAE, this is actually an example from Australia. And what happened is that they take the seawater, they pump the seawater, they screen it, it goes through filtration, and it goes through a very, very expensive process called reverse osmosis. The reverse osmosis is this. The principle is very simple. The scientific principle is very simple. Take a container and put a semi-permeable membrane, and at one side you put salty water, at the other side you have fresh water. You will realize that the salty water will pull the fresh water through, and then will increase its volume. That's in osmotic pressure. Now, in order to reverse the osmosis, you take the salty water and you exert pressure on it, and then it flows the other way. And that's what happens here. It's very expensive. And that's how water is being generated. A company in Israel has started taking salty water and putting that under a greenhouse equivalent, and then it evaporates, and as it evaporates, there's a condensate, and that water is recovered. And they are using this with a square meter. A square meter, they can get 10 liters of water every day. But other technologies are coming. A French company called Eol Water is generating 1,500 liters using a windmill. So the phenomenon is that here you see water evaporating because of the sun. Some clouds create precipitation, and that goes back in. But when you have the condensate, water in the cloud, research said that we have 13,000 cubic kilometers of water around the universe. So that is the biggest water reservoir in the world. The biggest freshwater reservoir is in the atmosphere. To be able to tap water from the atmosphere is the next technology where all scientists are working. So in the future, we will be getting water from the atmosphere. There is a student somewhere in the world who's working on a device, a bottle that is self-filled. You leave that bottle here, it will fill with water after a while, because it's taking the moisture from the air and then drawing it inside the bottle. And it will be pure water. So the water they're getting from here, from this windmill, is coming down. It goes through filtration. Another company here in Israel is showing this funnel-looking device, and is producing water. So water in the future, keep this in mind, that water in the future will be coming from the atmosphere. We will be drinking atmospheric water. Okay. Clean energy. Here, again, the only thing I will tell you is that there are other sources of energy around us. It's not just coal. It is not just petroleum or gasoline. Other sources are coming, and they are growing very fast. And today, I was just visiting a place in the U.S., in Colorado, where they are working. It's a government lab called NREL, Renewable Energies Lab. And they are working on grids so that you can integrate electricity coming from different sources. And just to give you an idea, you don't have to read the graph, renewable energies by 2040 will pass nuclear and coal by 2040. Some countries in the world are accelerating very fast in renewable energies. And there are cities that are fighting to get renewable energy 100% in their, for the city. I talked about additive manufacturing earlier. I'm coming back to it to close the loop with it. Additive manufacturing doesn't look at any shape. It can print anything that you have in 3D. Look at this shape. This is one of the most difficult parts in engineering. It is the part of the airplane. When you look at the jet engine in the airplane, the hub is in the middle, and then you have the contact, the interface of the hub with the propellers. And here, this part is being 3D printed right now already. It's being 3D printed by General Electric, GE, in the US. And this is a new car. 75% of the car was printed. They started the project in July, and in September they printed the car. And in the future, you will tell the car you want, and they will print it for you. 75% of this car is printed. The company in the US is called Local Motors. So Local Motors has started printing cars. Can we imagine printing cars in a garage? So in the future, all the jobs that we have on assembly lines that Henry Ford started at the turn of the past century will be obsolete. Cars will be printed. Just like Tesla Motors started in the US, self-driving cars, and all the big car manufacturers said it's not going anywhere, and now all of them are in the race for self-driving cars. It is predicted by 2030, 20% of the cars will be self-driven. I myself had a tremendous experience last year in Colorado. I went to a seminar in Colorado, and the guy who picked me up has a Tesla Model S. We were on the highway, he was driving, and at some point, he turned around and started talking to me. And I couldn't help it. I say, what the heck are you doing? Why don't you focus on driving? And he put his hands off, and on all the highway, the Model S was driving itself. I was fascinated. After 2 minutes, I had no problem about crashing the car. I was just fascinated being the technologist I am. It was fascinating to see that car. So well that the 3 days later when I was coming back, I asked to get the same car. But then it was snowing. The car was looking at the white stripes in the middle of the road, and it was snowing. So we couldn't see anything, and the car was still driving itself. So I asked the driver, another driver, what's going on here? You told me that the cameras have to follow the stripes in the middle of the road. He said, no, it is interpolating from the side of the road. So from a mathematician, the cameras are looking at the side of the road and then doing the calculation real time to keep the car on the road. That was fascinating. So this Local Motors is printing cars. So in order to wrap up here, you can see that everything starts on those 6 goals that we talk about, but with a quality education. Everything starts with a quality education. So we have to learn. We have to continue to learn. Our life is a lifelong learning. We never stop learning. And with a quality education, a nation will be able to have good health and well-being, clean water, industry. And with clean water and good health, we will have zero hunger. Zero hunger, for me, is not the starting point. Good education is the starting point. And then, with the industry, we can have affordable and clean energy. So, what are the opportunities? Before we conclude, modern technologies are offering to the developing countries. What are the opportunities to revise the education system? This is plain field. The clock is set to zero to all the countries on earth. So there's no country ahead of the other one. So any developing country today can catch up and can be competitive. So revising the education to give a spirit of entrepreneurship to young people. We can leap, any country can leap to a new technology without having to go through all the steps the developing country has gone through. You can leap to new technologies and innovative services and products can be developed. And again, resources will be plentiful around the world. Competent people will never lose a job because they will have employers from around the world. That's where we are going in 2030. But what are the headwinds? What are the roadblocks that we have that we need to overcome? What are the challenges? We need to develop a private investment culture in the developing countries. The private investment, meaning what? 2, 3, 4 people come together, they put money aside and say, let us start a new venture. We need to overcome the individualistic initiatives because no one succeeds alone. No one succeeds alone. I had a discussion with a young man once who was telling me, oh, I can do it by myself. As I say, no. Your father and mother have started taking care of you. And then you went to school, and teachers went above and beyond their salaries to teach you, to bring you up. And then medical doctors took care of you. Pretty soon, he realized that he would never have been in the position he was if it were not for all the people who contributed. Therefore, we need to overcome the individualistic initiatives instead, and then embrace partnership. Today, people want to do things. I want to do it only with my family so that we can control it so nobody can get in. Get up. Wake up. The world is not flat. It is round so that everybody can. And then banking structures. Banking structures are needed to feed seed money. People who have money need to get good ideas in order to put their seed money in those. And I'm asking here all of you that you need to learn how to write a business case, how to write a very good business case to attract investment in order to be creative and create your own. So, wrapping up, here are the 3 silent things that I will emphasize. Quality education, private investment culture, and with technology entrepreneurs. With those 3 things coming together, no country will continue to stay in poverty. No country. Quality education, private investment culture, and technology entrepreneurship. This may be the biggest challenge for the developing countries, but the other 2 are just an arm's length. I use this platform to launch a challenge to everybody in the world. I know that one day this forum outcome will be shared with others. And I want everybody to know that we can solve these issues by beginning designing and commercializing products and services that everyone on the planet can afford. There's one example, 1 billion lights. There is one person in India that started the 1 billion lights. One small solar panel that can only illuminate 1 light bulb They have sold more than 1 billion in the world. Because of that simple one light bulb, kids in villages can put that lamp outside during the day. It absorbs the sunlight. During the evening, they put it in one light bulb, and they can study instead of going by the street or studying with lights that are poor for their sight. Another company in the U.S. is working and is selling across Africa now and other parts of the world a small solar panel that will illuminate 5 light bulbs. So with those, I want to thank you for listening to me today, and I will speak French and go through quickly for those who